Hello, everyone. GM, morning, good afternoon, good evening, good night. Welcome, everyone, for lesson 16. Today, we have a lot to cover. We have a good chunk, piece of the APIs to finish from yesterday. We have the coupling of the front end and the back end, and I wanted to save at least 20 minutes for us to do the oracles explanation at the end. Okay, we integrated our front end with the blockchain in the first two lessons. Now we are integrating our front end with the our back end with the blockchain. Then we're going to integrate our front end with the back end. And then we're going to integrate our smart contracts with the information that we have in the back end. So it's going to be a full cycle, a full stack week. Looking around, I'm going to show the architecture. I'm going to mention about oracles like Chainlink now, and mentioning Telo. It's more like a composable architecture for us to understand the whole examples of oracles at once. Okay. The objective is to prepare you for the weekend project, and this is the biggest project so far in this bootcamp. It's going to prepare you for the final week. Is the biggest of this bootcamp indeed, that you're going to build a D app. Okay, so you are going to need a front end for sure. There is one feature here that needs to be in a backend to mint the tokens, cannot be minted in the front end, otherwise it would be a problem. We're going to implement that minting in the backend. We're going to connect those two. And that is a bonus task for you to use the Oracle to fetch off-chain data inside the smart contract for you to use in the app. So it's a very complete weekend project. We need to make every minute count here so that we can get there, okay? Unfortunately, I won't be able to pick too many questions today. I'm going to try and have everyone following as much as possible. But you know that you can ping me on GitHub. I have been solving some problems there on GitHub issues, on Discord, okay? Just because today we have a lot to cover. But in all the lessons, you know how I usually go slowly and step by step, right? So today I'm going to show coupling, front end and back end. So I'm going to open my cursor in the D app folder. So I have both the scaffold ETH and the token API there. I'm going to open my cursor from here. So you need to pay a lot of attention. If you want to go over this recording later, you need to go it slowly for you to know where I'm working with. I'm going to have a lot of tabs open on my terminal, one for the front end, one for the back end. So pay a lot of attention. I'll be working with those two folders, those two repositories. And I'm going to start the lesson in the token API. Okay, I'm going to start the lesson by finishing those post calls here. Here, minting tokens, those post methods for requesting tokens to be minted. Okay, I'm going to show the configuration for that. I have my server wallet there, This should take about 20 minutes or so. Once we finish that, we can move forward for coupling the front end and the back end, okay? So in the first 20 minutes or so of today's lesson, I'm going to use this folder token API. And I'm going to run it here in the terminal. I'm going to enter this token API, and I'm going to run the command npm run start to .dev so that it's going to be in the watch mode. Every change that I do in the file. So it's going to restart my API. And just to recapitulate the situation that we had. Oh, my calendar is open. Sorry about that. The situation that I had, I'm going to go for localhost. Let's wait for the server to start. Okay, started. Let me go for localhost 3000 again. This is my server working, so it can answer in the hood as this hello world. And if I want to explore all of the methods that I have available right now, I can go for the API route that is going to have a Swagger application running there, okay, so that I can interact with those items. For example, I want to get the name of this token that I have there. So the name of this token is cheese pizza token, something like that. Okay, the total supply is like this. Okay, so this is where we stopped yesterday. Okay, yes, Conrado.
Uh, I think I can see your sharing screen.
Um, wait. I,
I can
maybe
see.
it's your, maybe it's in your side. Okay,
Okay,
but please tell me
I will
if,
restart Zoom again.
yeah. The Zoom streaming has been very erratic in the last months. Okay. Well, also I wanted to highlight things more. Like it's difficult to see my cursor when I'm pointing to things. So at any time that if you cannot see what I'm pointing at, please let me know. Okay.
Okay, now I'm good here.
Okay. Okay. Good. So we have this working. It's there in the backend. We did those methods from from the last lesson. We did those methods from the controller, where we have a route for each of those things that we are calling. We saw that by architectural definitions, the controller is not going to do anything on its own. It's going to defer this job for the services. And we have those services here in this other file, app service, doing all of this process. Okay. And everything that we did in the past with those scripts and tests, minting tokens, transferring tokens, checking balances, anything that we implemented using VM, using this package VM, either with hard hat or even with scaffolding in the last lessons, we can do it now. We can pick the public client, we can pick the wallet clients, we can use those here. Okay, let me show some examples of that. Continued from yesterday's lesson. Okay, so for example, if I want to create a wallet client, I'm going to do those three controllers for us to um, actually let me do those two in the top first. Um, and then I'm going to go forward for the mint token. Okay, let me see what I have here. Okay. So I'm going to go back and forth. Pay attention. I'm going to do those two controllers only. Server wallet address and check mint role. Okay, I'm going to implement those two in my controller. Get the server wallet address and check mint role. I do have, this one should be async, sorry about that. I do have in my environment, I'm not going to show my env here, but in my env example I have put, I do have my private key set up in that project. So what this call is going to do is going to try and get the address of the wallet that is configured there with this private key. Okay, so let me create those two. Let me create the check mint role and the get server wallet address method. That yesterday's little trick of asking the IDE to code this for us. Okay. And I'm going to implement those two. I'm going to skip this DTO part for now. I'm going to do the post method later. I'm going to do those two by implementing these two services, the wallet client in the app service, okay? I'm going to modify the constructor so that I'm going to define this wallet client just like we did in the public client. Do you remember when we used VM instead of hard hat in lesson 8? How we could import the private key? You have all of that there on your previous scripts. I'm going to do the same structure. I'm going to create a wallet client by passing a transport, a chain, and an account that I'm picking from my environment. Let me prove for you that we did this snippet in the past, okay? It's going to take 30 seconds or so. I'm going to go there for the project 4. If we go for the scripts, if we go for deploy with VM, we have this already. Look here, I'm picking the deployer private key. here. When I'm creating that account, I'm using the private key to account, and then I'm going to use this account later for create a wallet client. We did that in the past. You do have that script there. So what I'm doing this week is porting this kind of content there inside of these frameworks that we are learning. So I'm going to do this constructor. Let me copy this piece of code. Let me put it there in the service. So now I'm going to actually no, I need to stitch my code a little. So I'm going to use this wallet client, and I'm going to declare this wallet client like this. I need to create this account like that. I'm going to import the create wallet client from VM, and the transport is going to be like this. Okay. I'm going too fast for you to code along, I know, but let me know if you are understanding what I'm doing. I'm copying the same technique that we did in the scripts in the lesson 8, and now I'm applying here in that service so that I can call the method create wallet client from VM and create that wallet client object that we have here. Okay, is that clear? Import this private key to account too. Import this private key to account. And then we can use, this is the same thing we did there in lesson 8. So that when we want to process those two methods, get several wallet address and check meter roll, I can implement them like that. Get several wallet address is going to just return the account address that we have in the wallet client, something that we were doing in the past with console log. Here I'm returning this call. Meter roll I could get from the smart contract like this, or I could just hard code like that. I know what is the meter roll. And then I'm calling the smart contract with the function read contract to see if the contract has this role or not. We did that in lesson 12 in a script using hard. Here we are using VM so that we need to pass the ABI and all of that. Hard would abstract all of that for us. Here we need to use VM directly. But this is not new. You know this, right? We're just applying on the backend part now. So if we call those methods, let me refresh my Swagger. So what is the address of the server wallet that I have? Is this address? What is the balance of this server wallet in this token? Let me try out. The balance is 0. Don't have balance at all on this token yet. Is this wallet a minter in that token? Let me try it out. Let me see. Internal server error. Let me see what happened. Has row. Oh, I guess that's funny. This smart contract I have is not access control. Oh, dang. The contract function has role averted. I have picked a wrong smart contract address. Okay. My bad here. Anyone would lend me any of your smart contract addresses? So I can use here. You need to have implemented access control. For some reason I did not implement access control in this. Yeah, from any of those tokens that you have used access control. If you haven't, I can try and search for one. But this cheese pizza token, what's the name? This token. Yeah, this cheesy pizza token token that I have, it's not implementing access control. My bad. I should use another address. But whatever, you got the idea, right? If you put your address here, you can check if you have this meter role or not, right? Good. We can't wait for too long, but if we don't have a token address here, we can just skip. Edgardo, thank you very much. Let me put that in my environment. Okay, I'm going to pause the share. I'm going to put that in my environment. This is going to be my token address. Now I'm going to resume the share and I'm going to restart my server so that it is going to pick the new environment variables. And let's see how this would go. I don't need to restart the Swagger. I just need to restart the server. Still going, let me execute. So this is the address you passed me, Edgardo. Thank you very much. What's the name of your token? It's my token. What is my balance on your token? I assume it's 0. Good. And do I have meter roll on your token? False. Okay. So when I try to mint, it's going to give an error. But Edgardo, if you're using this token, if you are minter, if you have this role, you are going to have true here, and you will be able to mint this token, right? If you have the mint function there. Okay. This is reusing part of the things that we did in last week's. Like I told you, this bootcamp is going to be reviewing and increasing on the things that we learned. So if you pick your past smart contracts and put here on this exercise, you should be able to get through in this meter roll and mint those tokens, okay? Questions up to here? Are you understanding? Maybe you don't have time to type it out, but are you understanding the flow of the lesson today? Yes, Johnson?
How did you come to this Solgar UI? How did you come to that?
To what URL, sorry?
This UI, you know, the explorer you are showing. Solgar UI.
The Swagger was this last configuration that we did yesterday.
Okay.
This part, Swagger model.
This
So,
Solgar, okay.
yeah, if you install this, you should have it working in an API route or something like that. Okay.
Clear. Yeah.
Okay. So that we don't need to go typing that on the terminal and our Swagger make it easier for us. So we completed these two methods here. Now let's start on this post method. Okay, this method, it has something that is called independency. It is independent. Independency. It means that the effect of a successful performance request on the server is independent of all the calls and or the actions to those same resources. Okay, a lot of ads popping up. Sorry about that. So if we do one get method here, where it is again. If we do one get method on my balance, or if I do 10,000 get methods on my balance, is this going to change my balance? Like my kid when we are driving, have you arrived yet? Have you arrived yet? Are we close? How long to get there? Have you arrived yet? Well, asking doesn't get us closer, right? So asking my balance doesn't change my balance, right? Here we are consuming RPC calls, so maybe some people could argue that this could be a post call. But if that was a read directly to a database, 100% get call. The results of successfully performed requests are not going to alter the results of all the requests, right? So get token balance, total supply. If I ask almost 1,000 of times, it's going to be the same thing, right? But with a post call, no. in a post call, if I halt it in the middle, or if I fail it, or if I do it twice by mistake, like a double fire, accidental double fire, triple click, it's going to have problems. So post methods, they are not independent. They require resources. If you ask it 3 times, you need to keep track. What was the first request, the second request, the third, and manage them properly. Okay, so they have a very different way for you to treat them. You have different ways to pass the requests, have different ways to handle them. Okay. So we're going to do this exercise very quickly. We're not going to finish the meeting, but we're going to implement it here in the API so that we can couple that later. Okay. I'm going to import post and import body from Nest. I'm going to import this and import that. And I'm going to declare this mint tokens there in the app service just to solve this problem. It's going to be here at the top. I'm going to copy that to the bottom. They could attach it to the bottom, right? It'd be better. I'm going to put it here so that it solves this problem. Okay, and I have this mint tokens here. But when I create the post method like that, Swagger is not going to know exactly what is expected in the body. Swagger is not going to read this line of code 50 to know that I have a body.address being requested here. Swagger is not that intelligent. It doesn't have this much of programming or AI on it. So we need to help it. When we use the get methods with those decorators, Swagger is able to tell what to expect. Like this token balance requires an address. This transaction received, it requires a hash. Swagger is able to tell. But just with a normal body, an empty body, Swagger is not able to tell what kind of body I need to pass. Okay, so when I pass this, it's empty. It's not that helpful. Okay, and we wanted to use Swagger to help us to interact with the API, right? So we're going to create an object that is pretty much going to be used just as an interface that is of the kind of DTO, a data transfer object. Okay, it sounds complicated, right? DTO, data transfer object, new kind of object, something else for me to study now. But here it's going to be very simple. It's just a class that we're going to use it to govern the interface of that body. Say that the body is going to have one API property that I'm picking here from Nest. Say that it's a type of a string. It is required. It defaults to this, my address, and like that. So don't bang your head against this description of DTO and all. It's just a class that's going to serve us as an interface. Okay. So this is my dog. It has ears, it has fur, it has 4 legs, it has a long tail. It's nice, you can pet it like treats. This is my dog. Go there, interact with it. Okay. I describe that for Swagger. So I'm describing what is this body that I want to receive in my call. I'm going to create that file inside a folder called DTOs, just for the sake of architectures, and I'm going to name this as mint tokens.dto.ts. I could call it just mint tokens.ts. Some people would argue. So I have this folder called DTOs. I have created this file mint token.ts just to put this class here. Is this going to create a database entry? Is this going to create accessors for that in the memory and blah, blah, blah? No, this is just a class that's going to be used as an interface. It's not an entity yet. There is no entity framework mapping or anything like that on Nest at this point. We could add, but for now, it's just an interface, okay? A data transfer object used for transferring data back and forth. So instead of marking this body as any here, I could mark it as mint token DTO, importing from that file. So you import the mint token DTO from this file that we have just created here. And just by doing that, now your Swagger model is going to know what kind of elements do I need in the body. Okay. Look, now the post of mint tokens is expressing that I need to pass this address here. Okay. And then you can implement these mint tokens. For example, let me see, I have it somewhere. You can implement this service of mint token. I guess I've put that in lesson 16. Somewhere I have that. Like this, I can implement mint tokens like that to return something. Like mint tokens is going to return a result true. Okay, fair enough. I'm going to get there eventually. So mint tokens, you know that I could implement that with a VM, picking the API and blah, blah, blah. So I'm going to do like, to do implement mint tokens, but here I would return something like this. That's a good suggestion. Like tokens minted successfully, success equal to true, and the address was like this, and I could put like the hash as this hash, like 0x example hash. You know where I'm going with that, right? You know how to mint tokens. We did that in the past. This is part of this weekend project. You are going to implement this mint tokens using the server wallet. Just a quick question for us to zoom out here. Why I cannot implement these mint tokens there in the front end? Why I need a backend using the private key of the minter and all to mint those tokens by request from the end user? Wouldn't it be easier just to implement this call there in the front end? Very good answer, Ivan. We need to keep the private keys private. If I put in the front end, it would leak. So in this mint tokens function here, I could charge for a payment. I could try and authenticate the user using signatures. I could try and authenticate the user using passwords. I could try and ask it for a proof of like post on social media, and I'm going to airdrop some tokens for you. So I can ask for a proof of a social media post. I can program this logic myself here in the backend. These kind of logics are very difficult for me to process in the smart contract. How to charge a credit card payment from the smart contract? It's very difficult. You need to charge in stablecoins. Not everyone would have stablecoins. How to check for a Twitter post in a smart contract? It is very difficult. We're going to see about oracles in a while, but trust me, it's much more tricky to implement that in an oracle. Here we are implementing that in a backend. We are a central point of failure here. We are a bottleneck. Yes, people will need to trust us. Yes, that is true. But they are needing to trust us anyways, not because of the backend. It's because of the business logic we implemented. You are only going to get this token if you post on Twitter. So this is centralized. We need to check. There is no like smart contract Twitter for verifying posts. Maybe we can use ZK, we can do some things like that. But in the overall architecture, decentralization was included before we even apply a backend. Okay? The backend here is not adding centralization; it's just automating this job for us, right? Let's close the zoom out. This is why we're implementing these mint tokens here in the backend. So the end user would call the backend and request, hey, please, can I have some token? So the backend would determine, yes, you can have some tokens, or you cannot have some token. Good. Before we start coupling, we kind of finalized the lesson 15 here. I have only 6 people with cameras open today. Just like that. Imagine by your expressions, Arda, Naya, Dante, Nathan. You're kind of serious today. Do you have snacks out there? Ivan, okay. Looking good.
I'm just
Okay, coffee.
making sure my code's legit.
That's good. Okay. So this finalizes the backend implementation. And now you guys can do backends for anything that you want. You can automate several actions. You can serve those scripts in the backend. You can serve those scripts in the front end, as we saw on Monday and Tuesday. And so far, we haven't coupled them, but now we know how to dispose of those two techniques: implementing user interfaces, UIs, the front end, and programmatic interfaces, APIs, with those backends. Okay. This is the current state as we finish lesson 25, and we're half hour deep. Let's speed up a little more. Now let's couple them. Let's make sure that the front end can call the back end for us to communicate those. Okay, let me explain why. There are a lot of things that the user is going to do from the front end directly. In this weekend project, for example, we are going to create a D app for the tokenized ballot. Okay, so for example, we want to display the proposals, we want to display my balance, I want to display the voting results. All of that I can do from the front end directly to the blockchain. Okay, Monday and Tuesday's lesson would be enough for that. I need tokens to vote, right? I need to self-delegate those tokens. And now, if I need tokens, I need someone that can disperse those tokens, dispense those tokens for us. So we are going to call the API. Hey, API, can I have some tokens here, please? And the API is going to say, of course, my friend, have one token here. I'm going to drip tokens for you. I would evaluate later for you to apply some sort of gatekeeping on this or signature now, but for this weekend project, this is enough. The front end should request those tokens from the back end. So there is no smart contract to intermediate that. It's purely an off-chain communication. Front end talking to a server. I'm going to show how to couple that. And you're going to see that backends can be very useful. For example, if you want to list the recent votes on the front end, on a public testnet, if you try to do that directly from the front end to the smart contract, it's going to be very tricky, getting all of those events, all of those past transactions and all. If you keep that in the backend, every time that someone makes a vote, you go there and store that in a variable. You don't even need a database for that. You can store in memory or in a JSON, whatever. You can display that in the front end just by listening to those events. It's very easy to see that happening, okay? Or you can even, you can sheet this a little. You can even make the front end calling the back end to store that log, and then you can visualize that in the front end, even from other computers. So this structure in this weekend project might prove why this integration of front end and back end is so interesting, okay? And today I'm going to show oracles in a while. It's going to be an extra thing for you to try out, but those two components, the front end and back end by themselves, is already something very interesting for us to interact with, okay? So coupling them. We are going to do this loose coupling. There are other frameworks we have used in Next.js. For example, in Next.js, you can have the same application with some files in the front end, some files in the back end, and then you import the same interfaces and all. It's very interesting, very powerful for you to get started, but it can get messy super quick. And if you want to use like a Python service, you need to do a lot of wrap around that and then deploy that on Vercel, blah, blah, it kills you. If you want to use a Go service, the same thing, you know. So I prefer to teach to start from loose coupled services, like microservices that can be written in any language. You are not going to import things between them. You just need to make sure that they comply by interface. They communicate by HTML, no, by HTTP or any kind of protocol to communicate them. And they have a breakable relationship, but so long they comply to the same interface, it's good. They don't have much of knowledge on how to implement things or what they inherit and all, but the interface is compliant so that you can replace them later. Okay. For a junior, this seems like a lot of complexity. What? Why do I need to do that? But for more mature applications that you want to build, more seniority and all, these kind of architectural work, this brings like sanity to your project. It's organized. Now you can maintain it easier. You can scale it. So these kind of decisions early on, if you carry this forward and make these decisions early on, you're going to avoid a lot of problems in the future. Okay. It's like spending $10 now to save 1 million later. So it's very worthy to have this kind of investments in the architectural phase. Okay. Not saying that you shouldn't do your backend in Next.js. I've used that a lot, for example, for serverless functions and all. But then I can tell you, I know a lot of people that are very annoyed whenever you need to integrate other things. A Python service here, a Go service there. Now it can get tricky. All of the easy parts that they give you sometimes, especially when deploying Vercel or something like serverless, all of this easy investment in the early days, it would cost like 10x more to migrate later. I'm going to show you here how this loose coupling would work, how those two would communicate between each other over the internet, okay? So I'm going to change the port for 3001 so that I cannot have two services running on the same port. So I'm going to change the backend. You could change the front end if you want, but I'm going to go for this main.ts here, and I'm going to change the port for the 3001, okay? And I'm going to have my front end running too. So I'm going to have two tabs. This one here of the token API running on the port 3001, and another tab. The computer is kind of slow here. So this is the backend, okay? And another tab in the front end. I'm not going to use the token API. I'm going to change directory to the scaffold ETH. This is going to be the user interface. So APIs and user interface in separate projects here. I'm going to run this with npm, no, yarn run start. So pay attention on those two. I have the backend here in the port 3001 and the front end in the port 3000. Okay, would you like this just to be in order, right? So my Swagger in the port 3000, I would need to open it in the port 3001. And my localhost 3000 is going to become the application, the front end of scaffold ETH, right? So now I have those two running. They are not connected to each other yet, but they are both running here in my computer. Now I'm going to change the home page in the front end in that index.tsx to create a new component for the API data that we did on Tuesday's lesson. And I'm going to add some components here, some I'm going to add like a card. I'm going to add a place for us to do this API coupling between one of them, one and the other. Okay, and we're going to have a lot of problems here for us to solve in the middle. Okay, let's go over that easily. I have those two things open here in my computer, front end and back end. And I'm going to navigate through those two folders here in my cursor. Okay, so pay a lot of attention for you to know what is what. I'm going to keep the controller and the service open in my cursor from the back end. And I'm going to open this file from the front end, from the user interface, package, Next.js, app, page.tsx that we were using on Tuesday's lesson. And we're going to edit both here. Okay. I have it compiled already. Let me see. Yes, I have. So this is what we did on Tuesday's lesson. We had this, right? I'm going to add in this page.tsx a small to-do here on that API. I have that. What is this? In the API data. Create a new component called API data. I'm not going to add it, actually, I'm going to add it. Let me forward all of those orders. Run a word, let me forward this, let me forward the token balance, token name, all of that we did in the lesson 14, right? Tuesday's lesson. So let me forward all of that, and I'm going to add this new component called API data. It's very similar to the component of random words that we did, okay? That's going to fetch a request from somewhere else. And I'm going to add this API data component there in the wallet info. This API data is going to receive this address. So similar to this token balance that it receives an address, but it's going to do the API call. I'm going to use this address later, okay? Let me import address from VM. We did that on Tuesday's lesson. And when I'm using it here, I'm going to use the address too. So I should modify the wallet info to include this component of the API data with address here, okay? I have it working on my backend. If I call something here, we go for the API, the Swagger documentation, I have it working. So if I ask for contract address or for token name or anything like that, it works. I can do this request and it answers, right? But when I try to get that from here, I might have some problems. Okay, let me see. I save it. Yes, API data. I should have a to-do here somewhere. Connect wallet to continue. Let me connect my wallet. Okay, so this component is only going to be displayed if I have my wallet connected, because I'm going to ask tokens to be minted from my wallet, something like that. Okay, so this is the to-do that we're going to work on. I have testing API couplings. It is to-do. And I'm going to get this information that we can get from Swagger. I'm going to get it to appear here. We're going to have a little problem in the middle. I'm going to show how to solve this problem. I'm going to create this component, get token address from API. That is going to do the same call that we just did in Swagger. Token address, contract address. We just did that in Swagger and it worked. But when we try to do here from our frontend, we're going to have a small problem, a coarse problem. Okay, I'm going to fetch this call. If I try to fetch this call from my computer, it works just demonstrated that it works. It's going to return something like this. But then now, if I try to get it from the front end, I'm going to have a problem of course. Cross-origin resource sharing policies, okay? As expected, this is like a security feature. So I'm going to put this token address from API inside the API data component. Inside this API data, where I have this to do, I'm going to try and display this token address from API. You can do it like this. Token address from API. Try to get this contract address and then displaying it like this. But this is going to give me a problem. Loading token address from API. Just trying to load this. Let's see. API is running. Go for the console here. Yeah, here. It's very small, but let me copy that for you in the chat. Access to fetch at this origin blocked by the course policy. My backend is not allowing us to request this information from other places. My backend is closed. This is about infrastructure, people. It's some sort of DevOps work that the backend is making sure that no one else, no unauthorized person can go there and call that method. Okay? Who can enter your house and grab a beer from your fridge? Some people can, some people cannot. You probably have this rule, this social rule. Like, if I'm your friend, may I do that? Answer me now. Just kidding. I don't even drink. But like, you should have these kind of rules with your friends. Like, yes, my close friend, my brother, my brother-in-law, they can. But my uncle Bob, that is always a drunkard. He is always telling bad jokes. This guy cannot enter in my house and grab some beer from my fridge. So these are the kind of policies that we have to configure here in the backend. Okay, we are going to do a very complex configuration to solve that. Okay, that includes changing 2 lines of code, and that's it. Actually changing 1 line of coding. If you want to know what is course, what are those configurations, what access it should allow or not, this is a very important subject if you want to deploy this to the public, to production. But for the net and express configuration with Nest.js, you just need to do that, enable course. Okay, so you're going to modify this main.ts in the backend. I even had it open here, main.ts, and I'm going to do one change. I'm going to find that app definition line that we have here, and I'm going to do this app enable course. So this is going to enable cross-origin resource sharing, different websites, or even if it's in localhost, but in a different port, now they're going to be allowed. I'm going to be able to make this call. Let me try this again. Did this ever restart? I guess it did. Loading. Connect wallet to continue. Let's see if the wallet will pick. And here I have testing API coupling. It's solved. Okay. I see a lot of people complaining about course policies, solving cores and all. If you use the right frameworks, the right techniques, and apply enough patience to that, it can be very easy to solve this. Okay. How to properly set up a course policy for production. Okay, then we need to stop and study a little more, get to the definitions, what kind of you need to do a regular expression to determine what kind of origins can call your API or not, for you to prevent attackers from brute forcing your APIs and all. Yes, that's important for productions. But for today, just for the show couple front end and back end, enabling course is enough. It's working. okay? We don't need to use a strong coupled framework, full stack framework, just because of cores. If we go there, it might be for other for other reasons, not because of avoiding cores, because as I demonstrated, it's very easy to solve that. You just enable that feature, and then you can decouple. You can build your backend totally separated from the front end, deploy it different places, scale it in parallel, do load balancing as you want, without paying $10,000 a month for a centralized cloud provider. And I'm liberating you for that. Now you have freedom to build your infra as you want, because we have the coupled front end and back end. Okay. And to finalize this lesson, preparing for the weekend project, before we go for oracles, I'm going to teach how to send a post call from the front end to the back end. Let's say I want to have a button to request tokens. I would fill a form. I would, before starting the ballot, I would click a button, fill a form, and then I would request those tokens to be minted to my wallet. Okay? And then I'm going to have another button to self-delegate. I'm going to request them to be minted from the back end. Okay. After this finishes, I'm going to have another button to self-delegate to myself directly from the front end to the blockchain, right? I don't need to deploy a private key for that. So I can do directly from the front end to the blockchain. And then I'm going to deploy the ballot, and then I'm going to cast a vote, see my voting power and all of that. This flow needs to be implemented in the front end. I cannot go there from Swagger and do a mint. My user is not technical enough for that, right? So I'm going to bake this in the front end. I'm going to have this function, this component, request tokens, that is going to have this button to request tokens. And depending on the result, this is going to display it worked or didn't work. We implemented this here, right? If it has data result, so I should implement result here, right? I guess I should do something like this, result, yes. This course of listening to me, for some reason, it knew that it, did you see that, people? I was going to encapsulate that in a result. It suggested this to me. I didn't type anything, but it did correctly. I was indeed trying to do this result like this.
It was probably the highest probability answer.
Yeah. Or they are listening to my microphone. One thing or the other. So this would be the result. And now I'm listening that in the page. Maybe it's monitoring my clipboard. In I had this piece of code in my clipboard, so it might have deducted that I need this result. Okay. Because it's checking data result. So if the AI was trained well enough, it should know that this is requiring the result member there in the body. Okay. So what I'm doing here, I'm using this body as this kind of object. I could even import the DTO that I have. There are ORM libraries like Prism and all that allows us to have this kind of interfaces between backends and frontends. But here I made it from scratch. I created this object again, the same DTO that I would have there in the backend. I'm fetching this information when I click this button from the localhost 3001 mint tokens. And then I'm going to display, if I have this result, I'm going to say it worked. Otherwise, I'm going to say it failed. I could even console log the result. Guess I didn't, but I could. Console log, like that. I'm going to put this button there inside the API data, just after the token address from the API. So I'm going to request these tokens when clicking this button. displaying the token address from the API, and then the request tokens. I don't need it to do anymore. Now, when I click this request tokens, this is going to go for Swagger. It's going to do this Minch tokens call here. And what I'm going to have, it booked. Look at the data. So this was the data success. And the result is token minted successful to this address. We copy this. Let me send for you here in the chat. Okay. So you know of your work in the weekend project, right? You're going to implement that mint token. This is going to take a while, like 10 seconds, 20 seconds for it to be included in the blockchain. When it's included, you get the hash, you get the transaction by hash, transaction received by hash, and then you answer here in the front end. Okay, you haven't minted this is now your balance, and now deploy, now self-delegate, now deploy. Console log does not print in the terminal. For printing the terminal, you would need to do a console log here in the backend. You see, when we do a console log here inside the front end, it prints in the browser. When we do a console log here in the backend, it prints there in the console of the backend. I could like console log address. Somehow crucial that I was going to do a console log here. I'm getting more and more convinced that it's monitoring my microphone. So if I do this call now, let me click on that button again. I don't know how long we're going to have teachers. I guess in a couple of years, or let's say 5 years maximum, the teacher could be an AI. Okay, so let's request tokens here. This is going to do the console log for me here in the chat, but it's also going to do the console log here for me in the backend. Okay. Good. Yeah, this is going to be AI. Everything's going to be AI. Okay. So this is coupling the backend and the front end. Completing that the app is part of your homework project. You should be able to complete this with the things that you did in lesson 8, with the things that you did in the lesson 12. Okay, you have all of those scripts and tests and snippets there. Should be easy to port them here. The backend is very close scoped, just the minting, and the front end you can use the scaffold ETH for building all of that. Okay. Browns, you should have those two running, okay? The front end from lesson 13 and 14, and the back end from yesterday's lesson. You should have both of those running for the to work, okay?
Okay.
And again, if you have any questions, any problems, please feel free to reach out on GitHub, on the technical channels there, on Discord, okay? I'm having average 1 to 2 questions per day. This is very low. Usually I have like 5 per day. There was a bootcamp where I had like 50 questions in a single day. It was a foundations bootcamp. We had like 200 people watching. It was crazy on the amount of questions. Of course, it's good when we can keep it manageable, but please feel free to ping me after the lesson if you have any issues, okay? Remember, at the end of this bootcamp, you should build a final project. Okay, and if you fail to build your final project, I'm failing as a teacher too. Okay, so it's a two-way relationship. Please make sure to post your questions to help me guide you. Okay, so that we can. Okay, this is a team job. We are a team, right? So let's do a teamwork here. Post your questions there. I'm going to help you to reach on the same point as I am. Okay. Yes, Dante. Questions here? Okay, the questions are coming. I ask and you shall have. Okay, good.
Dante going first?
Yeah, just real quick, can I get a screenshot of the top of uh the app service and the app controller?
Okay, let me summarize the changes that we did. And of course, you can screenshot before we have the recordings for tomorrow. So we did this wallet client, just like we did in lesson 8. And I implemented it, copying those lines that I had on the public client. Okay, if you want to screenshot, you can screenshot now. Okay. And what else we did? We implemented this get server wallet address and check meter role. This one I just copied and pasted from the README. If you want to screenshot, of course you can. And we prepared these mint tokens as a to-do, and then we coupled it in the front end. Okay.
Thank you.
Good. Do you want to screenshot the controller or the page TSX, something from here too? Here we basically copy and pasted from the README. No, not much of a change here. I guess just the console log that I just explained. Okay. So keep those questions coming. If you have any problems, I can debug through your code.
All the components on the front end are within this kind of app page, right? So we did not create separate files for them.
Yeah, this is not very organized, but we did them inside a single file in this bootcamp.
Thank you.
But it's good to separate them. I guess I mentioned that, but on the haste here, we skipped this organization, but it's good to have separate files for different components. Okay. Arda, you had a question?
Yeah, my backend and front end are showing my address that we defined in the DTO. What am I missing?
Showing my ad.
Yeah, there was a default in the DTO file.
Let me see if I find this file real quick. This.
There's a default my address, right? So my app is showing this instead of the address that we want. What I think I missed a step somewhere.
App service. So you're using address here. Maybe you implement it differently from this. But if you understood the flow, Arda, you have it there. So you can chill. If you understood the flow of this calling, then you can review. We can review together. Open your issue there, paste your code, and we can review it together. No worries. Okay.
All right.
Okay. It's not even be optimistic. It's like if you can't do this, I'm the one to blame. Okay, not you. So a good teacher is able to work with anyone from any kind of mentality. Some people are more like visual, some people are more auditive, some people are more practical, some people are more theoretical. So in one go here, it's not possible to explain like 4 or 5 different ways because we don't have time for that. So maybe the explanation is not ideal for you, Arda, or maybe it's not ideal for someone else. But later, when we can do the Q&A, I can tailor the explanation for how you want to understand this, and we can spend as much time as needed later. Okay, so I am very optimistic because I've been doing that for more than a decade, and if you can't do that, the blame is mine. It's not yours. Okay, working together here. Don't worry.
As a teacher myself, I don't believe that because as students need to spend enough time and effort also to be able to learn something. And I don't think so I'm spending a lot of effort, but it's clearly not enough. So I don't know.
The idea is that the better I do my job, the less effort you need to expend. Okay, so I need to improve and make the explanation better for you, my friend. Count on me. Conrado, tell me your questions.
Yeah, it's not the first time I've seen the Nest JS, and I'm a bit confused. You don't need to write the HTTP verbs, the request from the server side, so they can handle all this to me.
Yeah, the beauty of this framework is that it seems almost like a no code. Of course, we are needing to code a lot before implementing, but the amount of things that this framework is handling for us, like the amount of specific rules and infrastructure stuff that is being handling, like it's handling rate limits, is handling like DDoS protections, requests and all. So if you are used to writing backend code with Express, with Fastify or something like that, you might be used to have to write all of these little details by yourself. Nest.js is abstracting all of that for us. So it can make
Okay.
it very quick for anyone to deploy a backend.
Okay, you just to put in the deploy environment and to a portfolio, and you can do another upgrades in production environments as well.
Yeah, and it's very useful for hackathon projects. There is a lot
Okay.
of times that we need to do a backend, but people avoid doing backends like the plague. Oh my God, I need to do a backend. It's like, oh my God, I need to have a surgery on my leg. And I'm like, no,
Yeah.
you can pick something like that and very quickly you spin up your backend and you do something
Okay, thanks.
good.
Great. So my
And for-
address from API is stuck at loading token address from API message.
which call?
The token address from API on scaffold.
Maybe it's a course configuration. Check your console, you should have a course error. We did it very quickly up here. Let me show you that. And we had that problem too, and we had to solve by putting this line of code.
Okay, let me see. Thank you.
Okay. Nathan, you were asking there for the config service. Let me show you where is that. This is an optional implementation, but it's interesting to see. In the local variable part, I was showing before showing the Swagger model, I was supposed to show you this config model on how we can properly type the variables that we're importing from the environment by using this config model that is going to encapsulate the .m.config. But then we can do things like this. Config service get a string of token address from the environment. And then we can easily swap in and swap out environments, pick an environment just for the testing purposes, and then mock up these variables. So it is just one example of model that we can use from Nest.js. And it was supposed to replace the .env, but I did not have time. I didn't have the time to explain that yesterday, so we just skip it. Okay. So whenever you see in the constructor, I had this config service, and now you can remove. You can skip that part. We are not using the config service. We are using .env, but it's very easy to implement. If you want, takes like 10 minutes or so, just following those instructions here. From here to here. Okay.
I can attest to that. Just following the README, it worked for me.
Wonderful.
Very easy. I just have a quick, very pragmatic question. So whenever we update the backend code, do we have to restart the server, the token API server?
If you run it with this command, start to .dev, it's going to start in watch mode. So you don't need to restart it all the time.
Perfect. Okay.
Okay. Good. So the last thing that I have to explain for today, let's do a last push here for 20 minutes, people. The last thing to explain today is the final part of this cycle, picking off-chain information to use on-chain. For example, I want to do a smart contract that when it's rainy, the minting price of an NFT, it gets discounted by 50%. And when it's sunny, the NFT is on full price. How to get the weather information in a location like New York or whatever place we want to put that smart contract from the blockchain. I'm going to make a smart contract for bets. Okay, Brazil is playing Argentina in the final World Cup, and I'm going to bet that Brazil is going to win, of course, 100% chance. So how to get the result of that game? Of course, we know that's true, right? How to get the result of that game on chain? How to bring that on chain? I don't play football, but
After like
know
the
this is
Eagles game, you say this?
and this is a good subject.
4-1.
I'm just
My heart is with you, by the way.
I'm just a little upset that Dev Connect is going to be in Argentina, not in Brazil this year. But I'll be there anyway. So yeah, we're going to have some good asado. At least in barbecue, we can speak the same language. So the motivation for the Oracle pattern that we're going to study today is that all of the information on the Ethereum blockchain and all similar blockchains need to be validated by every participant and need to be deterministic, okay? So this is only possible when I have data from inside of the blockchain. The weather API, the football result game API, let's use another thing because with Brazil it's very easy to determine that it is always the winner, right? But with all the teams, let's say Germany is playing Chile or Australia is playing Italy. I don't know the result of those games. It's not that easy to determine. So how to put that on chain in a way that I can use that on the state of the blockchain on some smart contract, but without breaking the deterministic factor or the deterministic nature of the blockchain. And the answer is very easy. You can't. Wait, what? No, yeah, actually you can't. What you need to do is implement some pattern like Oracle patterns and all, where you are going to trust someone or some network to put that information in for you there. This article is very old, from the ages of Oracleize. Now it's called Provable Things, and now by 2014, where you had this kind of proposal. You have information that you want to get from outside of the blockchain, like Euro USD, the code of Euro to USD. You don't have that in the blockchain, or if it's rainy or who won that game and all. And then you want to use that inside your smart contract. So how to do that? You ask someone, the MSC sender need to be that address of that Oracle. You'll ask someone there off-chain to come here and put that result for you. Someone else is going to feed that information from off-chain to on-chain. So you cannot have it intrinsically there on-chain. I could do like a zero-knowledge proof that this information was not temporary. I can prove the program that generated that information now. Yes, I can do a lot of techniques, cryptographic techniques to ensure the validity of that computation, of that information and all. But ultimately, in last case, I cannot remove the figure of an external person, an EOA, an externally owned account, to go there and post that information in the blockchain. So whenever I want to get weather APIs, whenever I want to get results of games, financial data from stock exchanges, volumes of markets, like if my flight was delayed, I can get this information from the API. I'm going to stake this morning and then I'm going to get insurance. My flight was delayed. I'm going to receive this morning. Now, this information needs to come from outside the blockchain inside. This is done by an EOA. There is no smart wallet or nothing that can communicate with the real world and put that in the intrinsic level of the blockchain. Sorry about that. Which means that you need to trust someone, either a person or a decentralized network or some sort of structure okay? And the most famous players doing that, you can find a lot of Oracle providers. I guess this article is going to mention some of these. Most of the players doing that, they are going to create some sort of decentralized network or some sort of Oracle network to guarantee that you have much more to lose by giving a fake information than what you would have to gain from it. Because anyone putting that information would have a leverage, would have an advantage over the market. If it's the price of a stock, I would see the price of that stock first, right? And then I'm going to pay on the blockchain. So if the stock fell, I could sell first, and then after I sold, I could warn everyone else. Oh, that stock that I just sold, it fell, but it was just a coincidence, okay? Like most of the politicians do. Skip that subject. So they are exploitable. Whenever someone is putting this information here, this can be exploited. If it is the result of a game, for example, or if it's raining, I can have a discount. Someone could fake that information to get benefit out of this. So how those networks, they would solve that? We have examples, for example, Chainlink. Oracle network incentivized for providing accurate and safe information where they control who is being part of that network and all for ensuring accuracy. So it is handling millions, if not billions of dollars in volumes of assets, and it's working. We have like UMA, we have Telo that I'm going to explain. We have a lot of other Oracle networks. Now there is a lot of Oracle networks for AI, doing AI inference too, like Auras and Oasis. There are many of O's around there. We're doing those oracles for bringing off-chain data, like AI inference data is off-chain. They are doing that for bringing this on-chain. But that is always a problem. And I'm going to use Telo to explain this because it's visual. It's different from Chainlink and blah, blah, blah. Telo is not like a proposal for you to solve the Oracle problem. It's more like the building blocks for you to build a network. Let me stop my front end. In my back end, I'm not going to need those for now. I'm going to create a new folder here in closing. With Telo network, we're going to see that when building these oracles, we have like a trilemma. Let me explain the building blocks from here. Okay, and I have an exercise for us to test this later. In the Telo network, anyone can be an oracle. Anyone can request for information. Anyone can post information about that query that someone else is doing. But we have so the network, the design for this network, for this protocol is like permissionless. Anyone can come here and provide information. But we have a dispute time. So whenever I have information there, I cannot believe on it instantly. When I use all the networks like Chainlink, like those other that I mentioned, the information is there, you can believe it there now. But they are more like not that inclusive, not that safe now, because it could have a localized exploit and then someone else is going to be slashing. Yes, but still you lost money. Are you happy because someone else lost money too? So this whole discussion is a little more complicated. But let's see the building blocks here. I can answer any mathematical challenge very quickly. Any. I have this skill. My brain is prepared for that. So throw me a very difficult mathematical challenge for me right now, and I'm going to answer it in less than 5 seconds, okay, if our latency allows. Can ask here in the chat, and I'm going to answer it very, very quickly. Okay, this is a skill that I have. I tell that for interviewers all the time. So Ryan, the answer for this calculation is 42.4569, okay? I answered very quickly. Can you argue that that answer was quick? Okay, throw me another. I want to demonstrate this capability that I have for you. I'm just kidding, okay, people. What I'm doing is that I'm answering quickly but wrongly. Unless I was extremely lucky, this division that Ryan proposed, it should not be 42, anything close to that, it seems. A lot of different decimal cases, maybe 1,000, something like that. So whenever someone is asking for information, it's not enough to have a quick answer, right? I need to have an accurate answer. Everything that we do on chain, when someone puts wrong information, I'm trying to transfer something that I don't have a balance, it's very easy to see that this is a lie. But what about off-chain information? Someone else is saying that the price of euro to USD is 1.05. What tools you have to dispute that? Oh, no, that was too different from the last reading. Yeah, but what if the price crashed or peaked? Oh, no, you are updating it too late or too often. Wait, what about latency? So you don't have much of arguments to say that this information that someone is passing is true or not, okay? And this is a big factor for all of those oracles. You can never trust 100% the information that is coming. Yes, they have proof of stake networks. They need to stake money. If they do something wrong, they can be slashed. Yes, but this doesn't prevent the error from happening. If someone cheats a lottery worth $1 billion and they get slashed for $10,000, it's no big deal, especially with the tokens falling. Whenever they stake tokens and then the token price falls, they are incentivized for cheating when the monetary reward is higher than the actual problem. And sometimes they don't even get sued or persecuted or anything because sometimes they are anonymous, okay? Or they can allegate a hack or something like that. So it's very difficult to solve this problem, to solve this situation. What's the proposal of Taylor? And I like this one because it's going to give us the building blocks. Anyone can ask for data. So anyone can create a carry. I want to see the weather in New York. I want to see the Bitcoin price in dollar. I want to see the result of a football game from this and that. Anyone can create that carry just by picking the inputs, creating the schema of these inputs, putting that in a single in hexadecimal, in a single value, in a single call data or something like that, in a single object. So for example, for price for Bitcoin and USD, that would be the carry data. So it would be spot price of this asset and this currency. So, and you need to return this price. So this is our packet information. So you would have like this, and then that, and then that, and then this, and that, and that. You put all of this together, and then you create the hash, all of this, the keycack hash of this. And the probability of this carry, the hash being another one, like the hash of weather in New York being the same hash of Bitcoin price in USD is almost zero. We saw that already. So I want to get this information. This is my hash, and I ask for the network. Anyone has the information about this? And then I publish this carry ID. Anyone can fund these feeds. Hey, I pay $10 for anyone that can tell me if weather is raining or not in New York right now, for example. Okay, I can tip those carries, so I can attract people for answering that, or I can even pick information from a request, a query that is already being funded. There is already demand for this quote of Bitcoin to USD. So I can just go there and ask for this information, even if someone else is funding that carry, okay? Information is there, it's public. So anyone can ask for things and fund this question. Anyone can go there and become a reporter and start a report for those queries and getting paid, just as I was answering those mathematical questions very quickly. So with those two parts, it would work in the perfect world. Anyone can go there and propose information, correct or incorrect, and anyone can pay for that information. Okay. Any questions up to this point, Ivan?
Yeah, so maybe just is the teller really not just a library, how to integrate this into various networks, but also a marketplace? And the second question is, I will give you an example from my experience. I was calculating some risks for the actual lottery company, and they were doing kind of the copycat lotteries, let's say. So they were betting on the outcome of some other lotteries. And for example, in order to submit their bets for the insurance which they needed, they were using the timestamp. And then they had a claim on the insurance claim. And there, during the investigation, the question was asked, well, you know, these guys are handling hundreds of millions, whereas the service which is provided for the kind of secure timestamp of the data is earning a couple of thousands every month. So they would have a very huge incentive to whatever
cheat.
is supposed to be their private key, maybe not really be private, so that some data can be submitted to not a chain, but kind of to their database, even after the fact. And then there could be an false insurance claim. So kind of getting paid here could be very small compared to the money that we will be talking about as a dispute amount. So can you give us some color about how this could be handled?
Yeah, so this is the thing. It's not handled. This is always a money game, and the incentives are always going to be there. I wanted to make this clear in today's lesson. Oracles, they don't solve this issue of the information asymmetry. They always have a proposal for the solution. So Teller, it's nice because we see that playing out. We have the person that is wanting to get the data, for example, a random number, and then we have the reporter of this data. And then anyone can dispute that data. For example, I'm going to use a provable randomness generation, like VRF from Chainlink. If I try to cheat the lottery and say that I won, and I manipulate the random number so that I win, anyone could go there and open a dispute and say, hey, this guy cheated. We can prove that the timestamp was altered. The timestamp was supposed to be this, and then the hash would be that, and then here's the claim, and this can be voted upon. This is a governance process that is being put here. But you can always have collusion. We can always have bribery. We can always have siblings, and we can always get away without being persecuted or sued or anything here on the blockchain. Okay, this is a very actual problem that happens. Okay, this is the current state. Even like big players like Chainlink and other big Oracle protocols, they do have a lot of security because there is a lot of money in stake. But if ever any time you would have more prize to be gained by cheating than actually slashing to be done and reputational slashing and backlash to be done by cheating, you have incentives for cheat and then you're trusting someone else. It's not necessarily that the bad thing is going to happen, but you are trusting. That is a trust assumption there. Okay. Speaking of trust, you have a question from trust. Sorry for the play here.
Okay, yes. I was thinking of a case scenario where, for instance, you want to query, like you want to get data from, let me say, a private company. Like, let's say, for instance, now you want to get data from a Korea company directly into your program. How would you do such a case? Because I don't know if Oracle can also work there, or if you have a way of using their API or something on your project.
Yeah, so for example, using Tello, that is similar to using other Oracle networks inside a smart contract. You would import, you would inherit the Oracle here, for example, is using Tello, and then you would define an address of the Oracle. So if we look on the references here, what are the contract addresses for Telo? Or what are the contract addresses for Chaining? What are the contract addresses for Yuma, for Aura, whatever? So you're going to have those deployed in some networks, and you can call those oracles for this information. Hey, what is the information that we have there? Okay. So I have this working here on my computer. Let's see if I can do that in less than a second. I had this on the 2024 Q3. I have this there. I have a project on week 5, week 4 actually, right? And we have oracles. So I have a script there, npx how to run this deploy call Oracle. That is exactly the implementation of this. Okay, I have fixed that from yesterday to today. That is a little parameter here that we had to change. So make sure to get those recent changes if you want to run this script. And this is going to do like this. It's going to deploy this Oracle, and then it's going to try and pick the Bitcoin spot price. Okay. And it's saying that the Bitcoin is costing $57,000. Unless it fell a lot, this is outdated information from about a year ago. So that this network was a snapshot there on Sepolia. They have movement on mainnet, but in Sepolia, it's more difficult to have people paying for these updates. Okay, so this is why we're picking information from a year ago. So if you want to test that out on your side, you can run this smart contract. This is going to pick the Bitcoin USD information in Sepolia. And we know that Sepolia doesn't have any Bitcoin there. So this is an off-chain call. Okay. And that's it. That should prepare you for the weekend project. Make sure that you have at least 3 students in your group. If not, join other group, because it is going to be a lot of work. Okay. And if you have any issues on implementing that smart contract or implementing the app, implementing the function calls in the front end, coping the front end and back end, please make sure to reach out to me. Open those GitHub issues, send me messages on the technical discussion channel on Discord, okay, so I can solve all of this confusion for you. Good? Okay, so Trust, any follow-up questions on the Oracle too? Make sure to reach out, and I'm going to get to your questions as soon as possible. Okay. And that's it, people. I hope that you have a good weekend. This is going to prepare you for the final project. If it's the first time for you to build the app, it might be a little challenging, a little tricky, but that is a first time for everything, right? So in the second, in the third, in the fourth time, it's going to become more easier. And I'm here to help you through this weekend. Okay. That's it, people. Thank you very much. Have a good weekend. See you all on Monday.
Yeah.
Bye-bye.